what's going on? Welcome to Focus AI. So here in this video, we will learn one of the pre-processing techniques that we often use in most of the machine learning models before we feed the data into the model. Okay, so this pre-processing technique is called feature standardization. So what is feature standardization? Just think like if your feature data set or data set looks like this, okay, where it has some 5 to 6 number of data points and two features, feature 1 and feature 2. Now just closely see the values and or the ranges of the values of feature 1 and feature 2. Now in feature 1 you can see the range is quite high, it's in the ranges of hundreds. Like the minimum value is around 56, the maximum value is 315. While on the other hand, if you see the values in feature 2, it's in between 0 and 1, right? The minimum value is like around 0.26, maximum value is 0.98. Now, from these, I think you have guessed like what is happening actually. Like feature 1 is having a different scale, feature 2 is having another different scale, right? So there is a difference between the scale. There is a mismatch between the scales. So this is called something scale difference. Okay. Now scale difference occurs due to the different minimum and maximum ranges of features in the data set. Okay, and to be specific, scale difference affects machine learning models and specifically those model which is dependent on distances like Euclidean distance, because Euclidean distance acts differently in different scale difference zones. Because just think logically. Okay, let me clear the screen. Just think logically. Now, if there is a difference in feature 2 and the difference value is 0.7, okay, and if there is some difference in feature 1 and the difference is around 10, so intuitively or logically, what do you think, which difference is more with respect to their features? It seems 10, right? Because 10 is a, I mean, it's a uh, huge number than 0.7, right? Like it's 100 times, not 150 times, kind of. So 10 seems like a huge difference rather than 0.7. But just think, here the minimum range is 56, the maximum range is 315. So the range difference is around 250, you can say. And 10, how much percent does it cover out of 250? It's very minimal, right? But here the maximum value is 0 and the minimum value is 1. So 0.7 is actually 70% of the maximum value, right? So it's actually huge. Now, intuitively, logically, for the first time, you might think that okay, 10 is much more greater than 0.7. So obviously, the difference will much more in the feature 1. But think logically that 0.7 in feature 2 is almost 70% of the feature 2, like the maximum value of the feature 2, isn't it? So this actually happens while calculating the Euclidean distance, and if you just use these features as it is, then your model might not work well. So it's always a good practice to do feature standardization, or sometimes it is referred as column standardization, before feeding the data or features into ML model. Which ML models are dependent on distances? There are few ML models which are not dependent on distances, or scale difference does not affects on those ML models. But KNN like models that affects the scale differences. Okay, so how would you do the column standardization? So after standardization, feature 1 becomes feature 1 standardized and feature 2 becomes feature 2 standardized. Now, what is the formula? The formula is very, very similar. Okay. The formula is feature 1, I mean the feature minus the mean of the feature divided by the standard deviation of the feature. Okay. So what is feature minus the mean of the feature divided by standard deviation of the feature? So for feature, for the calculation for standardizing feature 1, what you have to find out? You have to find out the mean of the feature. Okay, so you have to find the average of all these values. Okay, then from each of the value you have to subtract that average and divide it with the standard deviation of these values. Okay, that as simple as that. So what happens is that now you can see from visual perspective, both feature 1 and feature 2 here after standardization is there is no scale difference. All are in the similar scale, right? And the most important part is that you consider this feature 1 standardized feature 1, or you consider standardized feature 2. Both will be having mean of 0 and standard deviation of 1, and there would be no scale difference. So which means now you are ready to feed your model into your machine learning. I mean, into feed your data into your machine learning model. Okay. Okay, fine. So this is a theoretical perspective. Just let me show you a simple small code snippet how you can implement it in Python. Okay. So here I am using Google Colab. Let me just zoom in a little bit. Okay, yeah. So here we are using Google Colab. You can use any Python uh, compiler, any Jupyter notebook, whatever you prefer. But I use generally Google Colab. Okay. So here we are importing NumPy, and here we are importing sklearn.preprocessing standard scaler. So standard scaler is a package under, I mean, is a module under sklearn package. Okay. So using standard scaler, you can directly get the values I have shown to you. But first, I will show you by using the formula how you can get this. So here I am creating the same feature vector. The same feature vector I have shown you. Okay. So this is the feature vector 1 or feature 1, and this is the feature vector 2. Okay. So now you can see there is a scale difference. Okay. Now what you have to do, you have to remember the formula, right? So what was the formula? Feature minus mean of that feature divided by standard deviation of that feature. Okay. So what I am trying to do is that I am just first getting, there are two features, so I'm taking the first feature column. Okay, and then I'm calculating the mean of that feature column using np.mean. I'm calculating the standard deviation of that feature column using np.std, and after that I am just consolidating everything and I'm getting the standardized feature by how? Feature column minus feature mean divided by feature standardization. Then I'm appending into some list and again converting into numpy array. Okay. So once it has done, if you call this function, the function name is colstd, column standardize. Okay. Now if you call this function with the feature vectors that we have created, now just see, it's there is no scale difference. That in the new features or in the standardized features there is no scale difference, and both the mean and the standard deviations are 0 and 1 respectively. Okay. Now this is the way you can do it manually by calculating the mean, calculating standard deviation, then getting the standardized feature values. Scikit-learn gives you a better way to do the same thing. So I have shown you that I have imported StandartScaler module from scikit-learn package. I have to just initialize an object for that StandartScaler class, and I have to use the fit transform method on the feature vector that we have defined. Then it will automatically give you that same result. If you see, the result we have created manually is similar to this. Okay, so in practice, when you standardize, you don't have to write such big functions that I have shown here. Okay, that I have shown here. You don't have to write this. You have to just import standard scalar, create an object of standard scalar, then use fit transform. Okay, so we will see the same similar thing when we will go through the KNN code examples, code walkthrough. Okay. Okay, so this is the end of the video. If you like the video, just do subscribe on my channel for the future videos notification, and do share with your friends and like the videos. Okay, so till then, have a nice day and happy machine learning. Thanks for watching.